Good evening. My name is Dinesh Vijayavardhana. Welcome to my program. Today we're going to learn about one physics topic called about waves, the sound wave, and their application. So let's get on to it. Basically, first we need to find out what is wave. Wave is basically we put it as a disturbance, or you can call it as a fluctuation, a disturbance that travel along or travel through a medium or a space. A disturbance that travels along or through a medium or space is called a wave. So now we need to find out what is disturbance. Disturbance is some sort of a fluctuation, like an atmosphere. You have some days that is has fluctuations in that atmosphere. So it's like something like that. So and so when there is a fluctuation, travels through a medium. Medium is usually um, like a like we can call it like air or water or even a gas like a hydrogen. So that's a medium. So any of these fluids, all of these called fluids, so any of these fluids can be used as a medium. So disturbance that travel through this sort of medium or a space. Space means like it does not have any content in it, so it will be like a vacuum. So so even in a vacuum the wave can travel, certain waves can travel, like X-rays, radio waves, etc. um, Now we need to find out, now what we know, now we learn what is wave. Now we need to find out how to interpret a wave. So if you put that in a graph, so graph like this. So basically in this graph, um, this axis, which is called x-axis, is for the time, and this one is for the usually the amplitude, which is the height. So now we put a graph in there. So that is a certain type of a wave that travel across a path. Or you can have another type of wave. If we erase this, or you can just put it over it, another type of wave like travel like that. So that is also a type of wave. This one is called sine wave. Usually in electronics you can find this sort of wave. This is called sine wave. The waves we usually see, like in sea or water or a fluid, is something like this. So if you consider like a surface of water, and we put a rock to it, onto the water. So this is like a tank. So once the water flows in, the water level goes down, and that creates a peak, and that peak travels all the way to here. So one moment the peak is here, and another moment the peak is there. So it just keeps traveling and traveling and traveling and hit the edge. Once you hit the edge, it comes back. So this is like a wave. This is a wave actually. So this is a wave that happens in a fluid. For example, that's water in a water tank. Like tsunami, that is also a wave. That tsunami that happened almost 15 years ago, that was actually a wave that created by an earthquake. It's an earthquake on the earth that pushed the water up and created a wave like this, and then it kept traveling and traveling. So it gave some push to the water, and then it kept traveling and traveling. So that's basically the idea of a wave. Now if we learn the next stage, now the next stage would be how to mechanically interpret a wave. So let's put like this. So this is one type of a wave, and this is another type of a wave, and we have the time here, and let's say the time in this particular amount is 1 second. Just imagine, and this is amplitude, and in a wave this is called one same point to another same point. The next same point is the period, or the wavelength. So, and that is the amplitude, that's the height. So if you put a normal equation that applies in science, that equation would be velocity equals f lambda. Basically the velocity is usually amount of the wave, that the speed of the wave, that travels on a certain path. So that is the velocity, but it has a direction. So that in this case, that's this direction, and this is that's velocity of the wave, and that's frequency. Frequency is how frequent the wave happens, how frequent the wave travels across a certain time. So in this case, this is 1 second, and this is a one wave. So it starts from this point. In order to reach the next same point is up here. So that's actually one wavelength, and in this case this is a one wavelength. So in this case we call this lambda. That's for the top one, and for the bottom one the wavelength would be this is 1. So that's what you call sigma here. So that's frequency. It's frequency times the wavelength. So if you do a simple calculation on this, for the top wave, first wave, the sine wave, That's the sine wave, and this is the cosine wave. For the sine wave, if you find the if you want to find the frequency, the frequency for the sine wave would be how many peaks, how many wavelengths you have traveled. So you got 1, 2, 3. So frequency usually depends on number of waves divided by the time. So number of waves 1, 2, 3 divided by 1 second. So the frequency would be 3 for that first wave, and the unit for this is called hertz. That is a name that derived by the scientists that who found this unit. And for the second graph, which is this one, that one is the cosine wave. That's the sine wave. That's a cosine wave. Frequency would be so we got one graph, because from same point to the next same point. So that's the starting point, and you go all around and come back to the same point. So that calls one wavelength. So you got one wavelength, and then you got another wavelength within this particular time. So frequency would be number of waves, and by the time, so number of waves is 2 and time is 1 second, so it will be 2 hertz. So basically, if you look at this, if you put these units in these equations, and then when you find out, you will find out that this particular wave, the cosine wave, travel faster, actually slower than the sine wave. The sine wave have more peaks within that particular time. So that's basically that's basically what a wave is in general terms. In next topics, we will learn how to what sort of different type of waves in topic of physics, and I look forward to seeing you there.